Hello everyone, this is Chandan and you are watching the learning field. So in this session we are going to discuss the real analysis questions paper of West Bengal SET exam, okay, 2022 paper, and this is the X series. The question number I here take from the X series. Okay, so we already solved the remaining parts of the questions paper of West Bengal SET 2022. Only the real analysis is remaining to solve. Okay, so those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and obviously subscribe the channel. Okay, so the all other videos link will be in the description. You can go to the playlist of WBSET mathematical science. Okay, the name of the playlist is this one. You can go to the playlist and you will get the all the videos related to West Bengal SET exam. Okay, and the upcoming SET exam in January 8 2023. Okay, that's why I take these classes, and yesterday I take a class on classical mechanics. You can also see the class. This is very beneficial for you with PYQs of classical mechanics. Okay, so let's start to solve the questions. The first question is question number 1. A polynomial px satisfying the following properties: p minus 1 equal to p0 equal to p1 equal to p3 equal to p4 equal to 0 and p2 this is not equal to 0. Okay, so what is the minimum degree of such polynomial is? See, this is very easy question if you think the question is in very easy way. Okay, why? Because see, there is minus 1 0 1 3 and 4 points. Okay, in the 5 points the polynomial is non-zero. That means what? We can easily we can write this polynomial as, suppose px equal to, we can write here x plus 1. Okay, these are the roots, minus 1 0 and x into, okay, x into x plus 1 into x minus 1 into x minus 3 into x plus 4, sorry, x minus 4, and the other terms also may include here, but these are the zeros term. Therefore this is the minimum degree of the polynomial, and you can take other terms also. Okay, and p2 is not equal to 0, it is given. Therefore the minimum degree of the polynomial is what? 1 2 3 4 and 5. So minimum degree of the polynomial is 5 here. Option B is correct here. Okay, go to the next question. This is question number 10. This is simply calculate the value. Okay, at x tends to 0 we calculate the limit of the function. See here, if we put 0 then 1 to the power infinity form. This is the form 1 to the power infinity form. This is the special case, and we know that if fx to the power gx happen in these types of form, okay, then we write or we calculate limit x tending to that and fx minus 1 into gx. Okay, this is the method to solve fx to the power gx and 1 to the power infinity form of the limit. And after getting or after calculating the limit, we just put the values in the exponential power. Okay, this value which we will get from this calculation. Okay, so now we put the values. This is equal to cos x minus 1 by sin x. Gx means is what? 1 by sin square x. That means sin square x, and take the limit as limit x tending to 0. Okay, so this is L'Hospital, you can easily apply. So limit x tending to 0 minus of sin x by 2 sin x cos x. Okay, sin x cancel, and if we put the value at x equal x tending to 0, then we get this is equal to minus 1 by 2. Okay, that means the value of the required limit, this is equal to exponential minus 1 by 2, which is equal to 1 by root under e. Okay, this is the answer, option C. Go to the next question. Let fx equal to 1 by x square and gx equal to 1 by x for all x belongs to closed interval ab with 0 less than a less than b. Then by Cauchy mean value theorem there exists c belongs to open interval ab. This is the definition of Cauchy mean value theorem. Now ab minus ab, that is f dash c by g dash c. This is, now we first calculate the f dash x and g dash x. So f dash x, this is equal to what? Minus 2 by x cube, and g dash x, this is equal to minus 1 by x square. Okay, so this is the value of f dash s and g dash x. Okay, now f dash c means what? F dash c equal to minus 2 by c cube, and g dash c equal to minus 1 by c square. Okay, so what this is the value. Now we put in the given form or in the Cauchy mean value theorem. So f dash c means minus 2 by cq by g dash c means minus 1 by c square. This is equal to ab means what? F of b means this. F of b means 1 by b square minus 1 by a square by 1 by b minus 1 by a. Okay, so this one. So this is equal to minus minus going to be cancelled, and this is simply 2 by c. This is equal to, this is, you can write 1 by b plus 1 by a into 1 by b minus 1 by a by 1 by b minus 1 by a. So this is going to be cancelled. So this is equal to 2 by c. This is equal to 1 by b plus 1 by a, and this is clearly the harmonic mean of AB. Since 1 by a, 1 by, if 2 by c equal to 1 by a plus 1 by b, then c is the harmonic mean of a and b. This is the simple definition. That means option C is clearly correct here. Going to the next question. If alpha and beta are two roots of the given equation ax square plus bx plus c equal to 0, that means since alpha and beta are the root, therefore we can write sum of the roots equal to minus of b by a, and product of the roots, this is equal to simply c by a. Okay, now if we calculate the limits, this is the 0 by 0 form, you can easily check. So limit x tending to alpha, okay, 1 minus cos of ax square plus bx plus c by x minus alpha square, this is equal to, simply we calculate, apply L'Hospital rule. So x tending to alpha, okay, x tending to alpha, okay, so this is the value sine of ax square plus bx plus c, and differentiation of this term, that is equal to 2ax plus b term by 2 into x minus alpha. If we also put the value, then this is also the 0 by 0 form. Then again we apply L'Hospital rule. So limit x tending to alpha, what? If we differentiate this term, then we again get 2ax plus b whole square, okay, and then cos of this ax square plus bx plus c, and plus both 2ax plus b means 2a into sine ax square plus bx plus c, okay, and then this is simply 2. Now cos of this is equal to 0, that means this is gives 1, cos 0 gives 1, and x tending to alpha means this is simply 2a alpha plus b whole square by 2, and if we put the value, then this term goes to 0 again, and but the options are not included in terms b, okay, the options are in terms of alpha and beta. Now we simply put the values of b from here, therefore we simply get b equal to what? Minus a into alpha plus beta. Now we put the values of b to here, which is equal to 2a alpha minus a into alpha plus beta, okay, and whole square, okay. So this is 1 by 2 into 2a alpha minus a alpha, means simply this is a alpha minus a beta whole square. So this is equal to half a square common and alpha minus beta whole square, okay. So this is option D, simply correct option. Going to the next question. The function fx equal to x to the power 1/3 for all sets or for all reals is not continuous. This is simply continuous function. You can check this very simple question. So this is continuous, therefore this option is not correct, and this is also differentiable at except 0, except at 0, okay. So this is also incorrect option. Now of bounded variation, now this is continuous and the derivative is also bounded derivative, okay. So if continuous plus it has bounded derivative, okay, we use this concept, bounded derivative, then it is of bounded variation, and this is simply x to the power 1/3 x to the power minus 2/3, that means this is x to the power 2 by 3. This is clearly a bounded derivative, okay. So this is of bounded variation, simply correct option, and A, B, D are incorrect option, okay. Going to the next question. This is a very important question, and this is based on error function, okay. Now first we define the gauge error function or simply error function by error function of x, this is equal to 2 by pi, okay, integration 0 to x e power minus of t square dt. This is the error function, and the values we need here: error at infinity, this is equal to 1, error function at minus infinity, this is equal to minus 1. If we put the values x, that is this integral goes to 0 to infinity or 0 to minus infinity based on, okay. And one more thing is that error function of minus of x, this is equal to minus of error function of x. These are the properties of error function which we need to use in this problem, okay. Now we can write this integration as exponential minus of x square cos of alpha minus x, we write cos of alpha minus x by, in terms of complex number, okay, which is equal to exponential iota alpha x, okay, plus exponential minus iota alpha x by 2 into dx, okay. So this is equal to simply 1 by 2 integration. If we break this integration, then we get exponential iota alpha x minus x square dx plus 1 by 2 integration e to the power minus iota alpha x minus x square into dx, okay. Now we simply write this 2 as, this is equal to 1 by 2 integration, what we can write, exponential minus of x minus iota a by 2 whole square minus a square by 4 into dx plus 1 by 2 integration exponential minus of what, x plus iota a by 2 whole square minus a square by 4, this into dx, okay. Now for this term we put u equal to what, x minus, we put 2x minus iota a, 2x minus iota a by 2, okay. So this one, this is equal to u, this means simply dx equal to du, okay. Then from this integration we get 1 by 2, and for this case we put u equal to 2x plus iota a by 2. In this case also, sorry, if we put v here, then dv is equal to dx, okay. So u and v we put here for these two integration, then you get simply 1 by 2 into and exponential this alpha square, this is, sorry, this is alpha, this is again alpha. So we this exponential alpha square, since these two terms are constant, therefore we can write this alpha square by 4 in the out of the integration, and integration of exponential of minus of u square and dx plus simply exponential 1 by 2 exponential minus alpha square by 4 integration integration, this is equal to exponential minus of v square into dv, okay. So now we put this integration in terms of this one, okay. We need 1 2 and 1 pi, okay. So this is equal to simply 1 by 2, we write here 1 by 4 into, yes, 1 by 4 into exponential minus alpha square by 4 into root pi in the upper side, and integration of what, 2 e to the power minus of t square by root under of pi into 2 v square, sorry, 2 u square, this is, and du, okay, plus 1 by 4, this is root pi by 4 exponential minus alpha square by 4 integration for 2 by root pi into exponential minus of v square dv, okay. Now this is the error function term, this is equal to, we can simply write pi root under pi by 4 exponential minus alpha square by 4 into error function of u plus root under pi by 4 into exponential minus alpha square by 4 into error function of v. Now this is the if we put these terms, or if we put now the values of u and v and put the upper limit, then the values of the upper limit, that is at infinity, error function value is 1, okay. That means this term goes to 1 in case of this integration, okay. Therefore we simply write here root over of pi by 4 e to the power minus alpha square by 4 plus root over of pi by this is pi by 4 error function, or sorry, this is simply exponential minus alpha square by 4. So this is equal to, simply the value is, I change the color, this is equal to root under pi by 4 exponential minus of alpha square by 4. This is the answer. Which option? Sorry, this is 4 plus 4, this is pi by 2. Okay, so which option? I think option A is the correct answer. Okay, now go to the next question. This question, which of the following series is not uniformly convergent on 0 1? Okay, so if we simply break this sum, okay, and take or write this as summation of x to the power 2n plus 1 by 2n plus 1 minus summation x to the power n plus 1 by 2n plus 2 term, and okay, then this term, this is clearly by Weierstrass M test you can check. Okay, these two series are convergent, therefore their summation or this subtraction is also convergent, therefore this is uniformly convergent. This can easily verified by using the Weierstrass M test. Okay, but this is not the uniformly convergent series. This is also the uniformly convergent series by Weierstrass M test. Okay, a very simple test. This one is, you all know that if we can write the fnx which is less equal to mn, and if this sequence is convergent, then the series fnx is convergent. Okay, you can use simply this test and you can get this a and c are convergent, but this b and d are both the not uniformly convergent series. But the answer, I think b given or d given, I don't remember that, but these two are the not uniformly convergent series from the given question. Okay, so I think only one option is given in the question. I think this question is wrong one. Okay, so this is the solution. And now question number 17 is r bar equal to r union this one, every sequence has a convergent sequence test. This is a very easy problem if we take an example. Okay, so if we take this xn equal to minus 1 power n, this sequence, okay, then the sequence is not convergent. So this is equal to, we can write 1 and minus 1. Okay, this is not a convergent sequence and therefore this is wrong. This is not a monotone sequence, this is wrong. This is not a unbounded sequence, this is a bounded sequence bounded by 1. This is also incorrect. This option only correct. Has convergent subsequence. Okay, if we take n equal to n 2n and even and odd term, then for even term we get 1, for even n we get 1, and for odd n, if we break this sequence as these two subsequence, then this is convergent subsequence. Okay, constant sequence, we get two constant sequence which are convergent. Okay, this is the solution. This is question number 36. Which of the following is true? Here the option only this is, you can say, the very statement based question. The Cantor set is totally disconnected set. This is the correct answer. And if you discard these options, then interval in real line are not only the connected set. Yes, this is correct answer, because any singleton set is also a connected set. Okay, this is correct, and this is also correct. Sorry, this is says not make the connected set, but this makes connected set. This is right statement. Okay, and this is also that true statement. Here it is not given. Okay, so the our answer is here option number D, the totally disconnected set, kind of set. Okay, now going to the next question, question number 38. Let f is equal to CAB, that means f is a continuous functions on AB, and small f is equal to infimum of ft, t belongs to this one, and mx, capital Mx is equal to this one. Okay, now if we just write the set, or we can just see the questions with an this is a very easy question. Okay, because see, if we collect the set of suprema set, this set ft, and take the supremum of the values, okay, and since fx is continuous here and there is a bounded interval ab, okay, that means what we get? Obviously we get supremum or infimum what with a single value. Okay, a single value after calculating this set or the elements of set, we get a single element which is a constant. Okay, okay, for the above set, and since f is continuous. Therefore, and similarly, since we get a constant for infimum and similarly we get a constant for the supremum, the functions first we calculate fx and then calculate the supremum and infimum of this set, then we get these two as constant. And here also given that it is a boundary interval, that means if we get to constant and constant function is always continuous function, therefore we can easily say that m belongs to CAB and m belongs to capital M belongs to CAB. That means what? These both supremum and infimum are continuous functions on AB. Okay, so these are the questions, I think, yes, of real analysis. Okay, so this is the solution of real analysis of WBSET 2022 paper. Okay, so if you like the content, then please give a like to this video, share with your friends and subscribe to the channel. Thank you friends, see you again in the next video. Thank you.